Today in geometry, we're going to look at 3.3 proofs involving parallel lines. Very important thing to note for today, okay? This sentence, you cannot use the theorem you are proving, okay? So if you are asked to prove a theorem, you have to do it without using that theorem. So the very first one we're going to look at, we're going to prove the alternate interior angle theorem. So I cannot use the alternate interior angle theorem here. Okay? Very important. I cannot use what I'm proving. Okay? So, statements and reasons given. Line M is parallel to line N. So they tell me that these two lines are parallel. They want me to prove angle 1 is congruent to angle 3. Okay? So given M parallel to N, given, I can use any of my other theorems I know. I can use alternate exterior, I can use corresponding, consecutive interior, I can use vertical angles. I can use any of that except alternate interior angle theorem on this proof because that's what we're proving, okay? So I need to get angle 1 and angle 3 into my proof without alternate interior. I see that angle 1 and angle 6, they are corresponding, right? Because I can give the same direction for both of them. They are both to the right and below a line. So I could say angle 1 is congruent to angle 6, the corresponding angle postulate. If I'm going to prove the alternate interior angle theorem, I need angle 1 congruent to angle 3. Right? That's what I'm trying to prove. So I've got angle 1 in my proof. So now I need to get angle 3 in my proof. But what do I notice? 3 and 6 are vertical. So I can say angle 6 is congruent to angle 3 by the vertical angle theorem. And now I've created a chain. 1 to 6, 6 to 3. So now I can say angle 1 is congruent to angle 3 by the transitive property of congruence. We just proved the alternate interior angle theorem. So now we've just proven that alternate interior angles are congruent without using that theorem. We proved that theorem. Okay? All right. And now we're going to prove the converse of the consecutive interior angles theorem. Okay? So given measure angle 3, measure angle 3 plus measure angle 6 is 180 degrees. Given, they're telling me that 3 and 6 are supplementary. Okay? They want me to prove line L is parallel to line M. Okay? All right, so in order to do that, I need to be able to prove some angles congruent. The only angles that I have are 3, 6, and 7. So I look at 3 and 6, I know they're not going to be congruent. 6 and 7 aren't going to be congruent, but 3 and 7 I see are corresponding. So if I can prove, so I need angle 3 congruent to angle 7, then I would be able to say that line L is parallel to line M. Okay. All right, so, and again, since I'm proving the converse of the consecutive interior angles theorem, I can't use that theorem. Okay, can't use consecutive interior angles theorem with converse of it. Okay, so let's get rid of that stray mark. Okay, I know that measure of angle 3 plus measure of angle 6 equals 180. I need to get angle 7 somehow in my proof. Okay? What do I know about 7 as it's related to anything that I have right now? I have 6 and 7, right? So, and I know that 6 and 7 are a linear pair, so I know that they're supplementary. So I could say the measure of angle 6 plus the measure of angle 7 equals 180 degrees. My reason, linear pair postulate. Now I need to get 3 and 7 together. I have two things that are equal to 180. I have equal signs. I can use substitution. So now I'm going to say measure angle 3 plus measure angle 6 equals, instead of 180, I'm going to substitute or replace that with measure angle 6 plus measure angle 7, because that also equaled 180 by reason substitution. Again, remember, you can only use substitution when you have equal signs. Now, they both have a measure of angle 6, so if I subtracted measure of angle 6 from both sides, I would get measure angle 3 equals measure angle 7 by the subtraction property of equality, because that's what we did was subtract. I need to prove that 3 is congruent to 7, so now I can change from equals to congruence by the definition of congruence. Now that I have angle 3 and angle 7 are congruent, I can now say that line L is parallel to line M based off of 3 and 7 are corresponding based off of the converse of corresponding angle postulate. Remember, anytime you're proving lines parallel, you must have the converse of a postulate or a theorem. All right, let's turn the paper over and look at some more back here. So here, given angle 1 is congruent to angle 2, so angle 1 is congruent to angle 2, given line A parallel to line B, given. So A is parallel to B. With that, I know then that C is my transversal. They want me to prove that C is parallel to D. So if I'm going to prove C parallel to D, then I would need to use B as a transversal. And what I need to get angle 2 congruent to angle 3 in order to do that. Let's go back with what do I know? Okay. I know I can use anything on this blue line on angle C because, or on line C, because that's my transversal of parallel lines that I do know. So I already have angle 2 in my proof because that was given. So now I need to get angle 3 in my proof. Angle 1 and 3 are corresponding angles. So I could very easily say that angle 3 is congruent to angle 1 by the corresponding angle postulate. Now let's see if I've made a chain. I could go 3 to 1, 1 to 2, so then I could say angle 3 is congruent to angle 2 by the transitive property of congruence. We just said we needed 2 and 3 to be congruent to each other. Now that they are, that is enough to say C is parallel to D. I'm proving parallel lines, so I know it's the converse of something. So the converse of what kind of angles are 2 and 3? They are alternate exterior. So it's the converse of the alternate exterior angle theorem. Let's look at the next one. Given, they tell me that A is congruent to B. So angle A congruent to angle B, given. And then they also tell me AD parallel to BC, given. So AD parallel to BC. So I know right off the bat that I can use this line right here, BC, as a transversal. They want me to prove AB parallel to BC, or sorry, AD parallel to BC, which means this red line DC is a transversal. So if I could get that angle B is congruent to angle C, then I would have enough to prove that that's a transversal and those two lines are parallel. So let's see, what can I do? Okay. If I know that AD and BC are parallel, so I said I could go off of this green line over here as a transversal, but I could also go off of this line as a transversal. Angle A up here is corresponding. This would also be an angle A right here. It would be the same thing, right? So now this transversal Since I know that these two lines are parallel, I could say angle A and angle C are congruent because they're alternate interior angles. So now I could say angle C is congruent to angle A by the alternate interior angle theorem. And now let's see, have I made a chain where I can get B and C together? I have C to A to B, so therefore I could say angle C congruent to angle B by the transitive property of congruence. We said as long as we got C and B congruent, then we could say that AB was parallel to CD. I'm proving lines parallel, so I know I need the converse. What kind of angles are B and C? B and C are corresponding. So this is the converse of the corresponding angle postulate. All right, let's look at another one. So here, given line L parallel to line M. So L parallel to M given. So I know this is this. They want me to prove that 4 is supplemental to 5. Okay, so let's see how I can get some of these angles in here. I can say that angle 1 is congruent to angle 5. That gives me angle 5 in my proof. I know that because they are corresponding angles. So by the corresponding angle postulate. I know that angle 4 is congruent to angle 6. I don't know if I need that or not, but I know it, so let's go ahead and get that. Gets me angle 4 in here. So angle 4 is congruent to angle 6 by the alternate interior angle theorem. I need to get 4 and 5 add together to be 180. I can say that angle 1 and 4 add together to equal 180. I can say that 5 and 6 add together to equal 180. So let's see. I could say that the measure of angle 1 plus the measure of angle 4 equals 180 degrees by the linear pair postulate, right? I know that angle 1 is congruent to angle 5, so if I change the congruence to equals and say the measure of angle 1 equals the measure of angle 5, a definition of congruence, I can now replace measure of angle 1 with measure angle 5, and I could say measure of angle 5 plus measure angle 4 is equal to 180 degrees by substitution. Now I have that 4 and 5 are supplements of each other, and that's what they asked me to prove. So now I can just say angle 4 is supplemental to angle 5 by the definition of supplements. So this up here, angle 4 congruent to angle 6, I put it in my proof, and I didn't need it in my proof, okay? I wasn't sure if I was going to need to get 4 and 6 in there in some way. I didn't, so if we wanted, we could go back and take that out. It doesn't really have anything to do with our proof. We were able to just go from 1 to 4, 180 by LPP, and then change so that we could use substitution. All right, so that is our very first day of looking at proofs involving parallel lines. We will have a homework proof worksheet that we will work on today and tomorrow, which will be due on Friday. And we will also be taking a quiz on Friday over these types of proofs.